This video will discuss how to use the inverse normal function with the ti-84 calculator. The inverse normal is used to find a value given a specific percentile. That percentile is what we're going to call the area. So when you use the inverse normal, so for what we've been doing, we use normal CDF when we want to find a probability or a percentage that corresponded to a specific value underneath the curve. This is going to be different because now we know the value of the actual area underneath the curve, and that area is a percentile. And because we know the area, we want to find the value that corresponds to it. So we're going to find that going backwards now. The calculator calculates a percentile. Remember, a percentile means that you are at or below a specific value. So we're going to find problems that are going to tell us to calculate a certain percent. When you see a percentage in a problem, that's the percentile you're looking for. You're going to calculate using inverse norm. The problem with that is it only calculates the left-hand side of the curve. So here's what I mean by that. Here's an example. It says scores for police training tests are normally distributed with a mean of 50 and a standard deviation of 10. So again, there goes that word normally distributed, so we should probably draw a curve and set the mean on that curve. An agency will only hire applicants with scores in the top 10%. What is the lowest score you can earn and still be eligible to be hired by the agency? So for this problem, here's what we're going to do. We're going to draw a curve. And on this curve, we're going to set the mean at 50. And what I'm interested in knowing is this now. I want to know what value corresponds to the top 10% or the top 10 percentile. So the top 10% is going to sit on the right-hand side of the curve over here somewhere. I want to know what is the x value that corresponds to that. In order to find this, the calculator, we're going to use the inverse norm. We're going to go backwards this time. And in order to do it, the calculator only calculates the left-hand side, this side over here. So we need to be able to calculate up to this value using this left-hand side. Well, if this side is the top 10%, what is this bottom part or the lower part? Well, this is the bottom 90%. So the percentile we're looking at is actually the 90th percentile. And in our calculator, we're going to go to second vars. And second vars is a function called inverse norm. Inverse norm wants you to give it that area, so that left-hand area or that 90 percentile here, which is 0.9 of the decimal. Express it as a decimal, comma. Then we can set the mean of the curve, which is at 50, and the standard deviation, which is at 10. We type those in, press enter, and we get the value that corresponds to the top 10 percentile is a 62.8 on the particular training. So let's try another one. This says the length of time employees have worked in a corporation are normally distributed, there goes that word again, with a mean of 11.2 years and a standard deviation of 2.1 years. In a company cutback, the lowest 10% in seniority are laid off. What is the maximum length of time an employee could have worked and still be laid off? So because we have the normally distributed word, we're going to draw a curve again. So let's draw a curve. Set the mean of this curve to 11.2. And now we're looking for the lowest 10%. So the lowest 10% sits on the left-hand side of that mean. And because the lowest 10% is at 10% and lower, we already have the percentile we're looking at. We're calculating actually the left-hand side, which is the side we can calculate with our calculators. So we don't need to change anything here. So in this calculator, we're going to do this. Second, vars, inverse norm. And this time, again, we're on the left-hand side, so we'll do 0.10, because that's 10% as a decimal. The mean is 11.2, comma, and the standard deviation is 2.1. Close the parentheses and press enter, and I get 8.5. So the maximum time an employee could have worked is 8.5 years and still been laid off.